Given are two statements S1 and S2 asking that there exist infinite sets A, B, C such that A intersection B intersection C is finite. There exist means that is there any possibility or any single case such that A intersection B intersection C. Suppose that A is set of integers, B is set of all positive integers and C is set of all negative integers. It is saying that A, B, C are infinite sets. I have taken example of all infinite sets. A set of integer, B positive integer, C negative integers. Now see it. A intersection B intersection C. Since B is a set of positive integers and C is a set of negative integers, so common element between B and C is 0, that is phi intersection A. A is a set of positive integer, A is a set of all integers, and phi. Common element between two set is again null, that is again phi, that is A intersection B intersection C. All are infinite, but intersection of all is finite set. So statement S1 is correct. Now I will check statement S2. S2 said that there are two irrational numbers x and y, two irrational number such that x plus y is rational. Rational means a number of the form p by q where q is not equal to 0 and p comma q belongs to integer. Irrational means non-terminating and non-recurring. Decimal means after decimal number is neither stopping, not terminating, and neither repeating. It is irrational. Example of irrational number is pi, root 3, value of e. So I have two examples. Let's say x is 3 plus root 5 and y is 3 minus root 5. If you add both of them, you will get 6. Means it is one irrational number, it is second irrational number, the result is 6, that is rational number. So statement 2 is also correct. Answer is C.